Today we're going to talk about dimensional analysis. Dimensional analysis is a tool that we use in chemistry to solve problems. We're going to start off with some pretty easy problems, and you will probably think that there are easy ways to solve these problems. And in these cases, sure, there is. But right now we're teaching you a foundational skill so that when we get to things a little more complicated, you already know how to use this skill and you'll be able to apply it to those problems. So we're going to start talking about dimensional analysis, one-step problems, and then we'll move on to multiple-step problems. Okay, so dimensional analysis is a powerful, very powerful problem-solving method that's based on the fact that you can that any number of expressions can be multiplied without changing its value. In other words, what we're going to be doing is we're going to be using conversion factors, which are just fractions. All we've done is all we'll be doing is multiplying and dividing fractions, and you already know how to do that. But we know that there's equivalence in these fractions. So if we were to say 1 dozen eggs, that is the same thing as 12 eggs. Okay? And we use that in order to convert between units. Remember, every measurement must have a unit, a number and a unit. And we can make two different fractions out of each of these conversion factors. Okay, for instance, we know, because you've learned this, the last unit, that 100 centimeters is equal to 1 meter. That can be written as two fractions. You can either write it as 100 centimeters over 1 meter, or you can write it as 1 meter over 100 centimeters. Those are equivalent things. 1 meter always equals to 100 centimeters. The other way you can write that is we know that 1 centimeter is 0.01 meters, or 0.01 meters is equal to 1 centimeter. And that's because centi means 0.1. This prefix, centi, means 0.1. So if you replace that C with its meaning, that'll give you this equivalence factor. You could also write, you can say that a pizza has 8 slices. A pizza has 8 slices, and you can write that as a equivalence factor too. You can either say for every pizza has 8 slices, 1 pizza over 8 slices, or you can also write it as 8 slices over 1 pizza. Those are equivalent statements if you're not changing any meaning to it. Another example, if you're looking at something like density, if you have the density of something and it is 5 grams per milliliter, that means that if you have 1 milliliter of that object, it's going to weigh 5 grams. Or if you have 5 grams of that object, you're going to have 1 milliliter. So you can write that as 5 grams over 1 milliliter or 1 milliliter over 5 grams. Those are equivalent statements. One last example. If you say something costs $1.99 per pound, you can write that as $1.99 over 1 pound, or you can write that as 1 pound over $1.99. Those are equivalent statements. They mean the same thing, but it's a way of converting between units. The very top, converting between meters and centimeters. For the pizza problem, it's converting between pizzas and slices. In the density one, it's converting between grams and milliliters. And in the money one, it's converting between the cost per pound. Okay? So to give you the format of what dimensional analysis looks like, you will be given a problem, and in that problem, there'll be something that is given and then something you want to solve. And you will use these conversion factors, these equations, to convert between them. And you'll see it written many different ways. You'll see it, they're given over 1, you always put it over 1, times a fraction, one of these equivalent factors, times another fraction, times another fraction. Or you'll see it written like this. And this is how I'm going to be writing it. These are still fractions, a number over a number, a number over a number. It's just less writing, you don't have to do little x times, okay? You're always going to use 1 as a spot filler, so it reminds you that these are just fractions. Okay? Every time you write something in here, you must have a unit, and this is going to make sense in a minute. Okay, but first, let's start without a unit. First, let's show you what this means. Okay, if you were given numbers in this format in order to solve, how would you do that? There are several ways you can do it. Because these are just fractions that you are multiplying. There are several ways you can solve it. You can do multiply 10 times 13 times 6 divided by, in parentheses, 2 times 4. So everything on the top multiplied divided by everything on the bottom multiplied, and that's this method right here. And that gives you 97.5. That's 3 significant figures. Technically, this answer should be in 1 significant figure, but that's a different issue. The other way you can do it, and this is my preferred way because I can keep track of it with my finger, is I can say 10, I cross a line, so 10 times 13, then I go down, divided by 2, times 6, divided by 4. Let's do that again. 10 times 13 divided by 2 times 6 divided by 4. It'll give you the same answer. And you should try this on your calculator. The other option, because you're just multiplying fractions, is you can just multiply the top and write that number. Then multiply the bottom and then write that number. And then divide the two. Okay? So let's have you try it. So right now, pause the video and try it out. Whichever method works best for you, or try them all and see which one's easiest. Again, what I would do is this divided by this, times this, 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 divided by that. When you do that, you should get this answer. Try it out. Okay, so the other thing we're doing is we're just canceling out units. So all these numbers should have units in them. So you can have centimeters, and then the next fraction you have inches over centimeters. So you have a conversion, one of these equivalent statements between inches and centimeters. If you do this, you're just multiplying centimeters times inches divided by centimeters. So your centimeters cancel out. Here, so then you're left with inches. Then you have inches, so centimeters cancel out. Then you have feet, conversion between feet and inches. Your inches cancel out. Then you have conversion between feet and yards. Your feet cancel out. So that means your final answer is going to be in the unit of yards. So when you're using dimensional analysis, you are taking into account both the number and the unit. The reason this method is so powerful is because you have these units. These units serve as a check for your work. If you've set everything up correctly, then you should end up with the unit you need. If you didn't, then you've made a mistake. This checks your work for you. Okay, so let's try here. So if we were trying to convert between weeks to seconds, we would say from 1 week, we know how many days are in a week. And those cancel out. We know how many hours are in a day. Those cancel out. We know how many hours are in a minute. The hours cancel out. We know how many minutes are in a second, or we know how many seconds are in a minute, so the minutes cancel out. Whatever you need to cancel out goes on the bottom, top to bottom. They cancel out, top to bottom, top to bottom, top to bottom. Final unit is seconds. Let's put that together. So let's say, so I'm going to show you a complicated problem, and then we'll get a little more simple. Let's say I want to know. I have 3 weeks, and I want to know how many seconds those 3 weeks are. Do you know how many seconds are in a week? I don't. I don't know how many seconds are in a week. So what I would do in this case is say, well, you know what? I don't know how many seconds are in a week, but I know how many days are in a week. And then I can say, wait, do I know how many seconds are in a day? No, but I know how many hours are in a day, so I can convert to hours. And then I can convert to minutes, and then I can convert to seconds. When I do this, first thing happens is our weeks cancel out, our days cancel out, our hours cancel out, our minutes cancel out, and we're left with seconds. So we set up this problem right because we're trying to go from weeks to seconds. So because we ended up with seconds as our unit, then we know we set it up right. So now we can actually enter this into our calculator. However you want to do it. Again, my preferred way is 3 divided by 1 times 7 divided by 1 times 24 divided by 1 times 60 divided by 1 times 60 divided by 1. Your units is seconds. Your final answer is 1.8 at 1,814,400 seconds. Okay. So let me show you why we're doing problems like this. So this is something we'll be doing later in the year. This is much later, probably this is third term. So you have a problem like this, and we know that we have 5 grams of magnesium, and we want to know how many grams of magnesium oxide can we make. And we know our ratios that have to do with something called moles. So if we wanted to solve, and then we know also how much magnesium weighs, and we know how much magnesium oxide weighs per mole. So if we want to figure out how many grams of magnesium oxide we would do it like this. We start with what we're given. We multiply by what's called the molar mass of magnesium. Then we use our mole ratio. Then we use our molar mass of magnesium oxide to give a final answer. This is what we're trying to get to. So if you notice here, this is 4 steps. Sometimes your problems will have 6, 7, 8 steps. The reason this is such a powerful method is because your units will tell you if you did those steps correctly. If you don't have units, you will make mistakes. This is where we're headed. We're not there yet. We're going to start with 1 step. Okay. So when you're using dimensional analysis, what you do is you start by writing what you want, what you're given, what you want, and those ratios, those equivalent statements. You're going to identify what you're given is in the problem. You're going to determine what units you want, what's given, and where are you headed. Where did you start and where are you headed? Then you're going to choose those equivalent statements that will allow you to convert from your given to your want. Okay? To set up your problem, you're going to start with your given as a clean fraction. That means your given is just a number with a unit. You're going to put that over 1. Make it a fraction, right? Put it over 1. You're going to write your multiplication symbol and place your ratios so that everything above and below cancel each other out diagonally. Any units that did not cancel out are part of the units in your answer. So we're going to start by doing it in an easy manner. We're going to start by doing 1-step conversions, and we're going to do it using something that we've already done, which is converting between the metric system. We learned how to move decimals in the previous unit. We're now going to learn how to use dimensional analysis to solve the same types of problems. This is my preferred way of doing it because it makes things a lot easier, only remembering one method. And you don't have to remember, do I move to the right? Do I move to the left? You just need to know that relationship between meters and one of the other, between your base unit and one of the prefixes. So let's start with doing one like that. So let's start with calculating the number of meters in 163 centimeters. So we know from the previous unit that 1 centimeter is equal to 0.01 meters. Centi means 1 times 10 to the minus 2, which is the same as this number. It's a prefix. So if we replace the prefix with its meaning, you get 1 centimeter is equal to 0.01 meters. So look at this. This is an equal sign. And remember, when you have things in an equal sign, you can make an equivalent statement. You can make a fraction out of it. So we're going to do that in a second. But first thing you're going to do is you're going to say, what are you given? What is given to you in this problem? And what's given to you is 163 centimeters. What unit do you want? Where are you headed? You're starting with centimeters and you want to know meters. So we're going to write down our want is meters. And then we're going to write down our ratios. In other words, our fractions. So what does that look like? Okay, so we're given 163 centimeters. We want meters. And we know that 1 centimeter is equal to 0.1 meters because we have that memorized. Okay, so let's set up our problem. First thing you do is you write down the given over the number 1. You don't have to write that 1. It's a good habit to get into, so it reminds you that you're just multiplying fractions. You write 163 centimeters and you put it over 1. Okay? So now we need to convert this to meters. We want centimeters to go away, and we want to end up with meters. Do we have a relationship that ties centimeters and meters together? We do, right here. We know that 1 centimeter is equal to 0.01 meters. So we want centimeters to go away. So we're going to put that on the bottom, because if we put centimeters on the bottom, our centimeters will cancel out. I always like to put the thing I want to cancel out first, write that first, and then write the other part of the fraction second. So we're going to write 1 centimeter. So for every 1 centimeter, we have 0.01 meters. You put it there. So what does that give you? If you enter that into your calculator, you're going to get 1.63 centimeters. Now go back and look at your chart. How many spots did you have to move your decimal? You had to move it 2 spots. Which direction? You had to move it to the left. Look at this. We got the same answer, but we're not done, because we need to write our unit. If you don't write your unit, your answer is incorrect. We know that our centimeters canceled out, so we need to write what unit we have left, which is meters. This is 3 significant figures, so your answer must also be 3 significant figures. Okay, let's try another problem, but this time we're not going to use the metric system. We're just going to do a regular conversion between inches and centimeters. This question says we want to know how many inches we have in 163 centimeters. So same problem, but instead of going to meters, we want to convert to inches. Well, we know the conversion between inches and centimeters. You don't have to have this memorized. This would be given to you, because I would never make you learn a conversion between something not metric. You have I'm telling you, 1 inch is equal to 2.54 centimeters. That's something that we know. So step 1 is we write what is given. What is given to us? Given to us is 163 centimeters. That is where we're starting. Step 2 is we're going to write what unit we want. What are we trying to find? Inches. We're trying to find inches. Step 3 is we're going to write our ratios. We ready to have this here? That's what we're going to have. So we're starting, we want inches. Where did we start? Given. And our ratios. Our 1 inch is equal to 2.54 centimeters. So when we go to solve this problem, we write down our given over 163 centimeters. Put it over 1. Okay, we want centimeters to cancel out. In order to cancel centimeters, using our ratio here, we want this part of our fraction to be on the bottom so that the centimeters will cancel out. So you write 2.54 centimeters. So if we wrote this part, we need to write the part right above it, 1 inch. Okay, so enter that into your calculator. 163 centimeters times 1 divided by 2.54. You get this number. What units do we have? Well, our centimeters canceled out. We're left with inches. Okay, so this is what we get when we get in the calculator. It's a little more than that. But we need to see our significant figures. Okay, well, how many significant figures do we have here? We have 3. So we're going to say 3 significant figures, 64.2 inches. Now we're going to run through several more problems, but you can pause this video and go back as many times as you need. Okay, let's do another one. Let's determine, so now let's do something that's non-science. Let's say you can use this for many different things. Let's say we want to determine how many tires are on 623 cars. Most of you know just to multiply that number by 4. But we can do this problem using dimensional analysis. Again, we're building a skill set with easy problems, and then we will work our way up. So what is given? We write what's given, what we want, and our ratios. So we know 623, that is given. That's how many cars we have. What do we want? How many tires do we have? What is our ratio? Every car, one car has 4 tires. One car equals 4 tires. So if we were to solve this using dimensional analysis, we'd put our given over 100, our given over 100, given over 1, and then we want cars to cancel out. So we're going to put cars on the bottom and tires on the top. When you do that, your cars cancel out. And you're left with the unit tires, 2,492 tires. Now here we have infinite number. This is an infinite significant figures because you're counting, you're itemizing. Remember that case we talked about things where you have infinite significant figures? This is a case where you have infinite significant figures. This is infinite because you have 623 cars exactly. For every car, you have exactly 4 tires. So this should be infinite significant figures. You can just write it like that. However, for this case, let's just pretend we're going off of the very first number. And so we'll just say 3 sig figs. So if you were going to do 3 sig figs, you would just write 2,490 tires. That's 3 significant figures. Okay, let's try another one. So what if you have this sort of thing? A car is traveling at a constant speed of 55 miles per hour. 55 miles in 1 hour. This car can go, in 1 hour, can travel 55 miles. How many hours? You want to know how many hours will it take to travel 19 miles? Okay, so what is given? So what is given here is 19 miles. Your given is always going to be a solitary number without a fraction. What do we want? We want to know hours. And what are our ratios? Actually, our ratio is given in the problem. Okay? Our ratio is given that for every hour, we're going to go 55 miles. So here, our ratio was given in that, or our equivalent statement was given in that problem. So we're going to start right our given over 1. So remember, the thing that is by itself that doesn't have a fraction, that's usually going to be your given. So you can put it over 1. We know we want miles to go away, so we're going to put 55 miles on the bottom. But if we use the 55 miles, we have to use the hour portion too. So that's going to have to be on top. So your miles are going to cancel out, and you're going to end up with 0.345 hours. 2 significant figures, because here this is 2 significant figures. So 0.35 hours. Okay. So now let's do another problem. So determine the number of dozen eggs in 3.84 times 10 to the 3 eggs. Oh, look at that. You're going to have to use scientific notation with your calculator. So let's do an example. What are you given? Well, what you're given is the number of eggs. What unit do you want? You want dozen eggs. So I like to, if I'm doing this on paper, I like to circle where I'm starting, my given, and I like to put a little box around my where I'm headed. Okay, we're going to list our ratios. We know just from life that 1 dozen is equal to 12 eggs. Okay, so let's set up our problem. Write down what we know first, over 1. We know for every 12 eggs, we want eggs on the bottom so that it'll cancel out. You have 1 dozen. That gives you 320 dozen eggs. Put that on your calculator. Make sure you get that answer. Make sure you know how to enter your scientific notation. Okay. 3 sig figs. So the way you show that that is 3 sig figs is you put that decimal right at the end. Right at the end. Okay. We're not going to do this problem in class, but just so we'll do it here on this video to give you another example. So here it says, use the back of your periodic table to convert 120 calories to joules. Notice that's 120 with a decimal after it. It means 3 significant figures. Okay, so you don't have a periodic table, but I'm going to give you the ratio of how to convert between calories and joules. But first of all, what is given? 120 calories. That is what we know. What are we trying to find? Joules. Well, we know that 1 calorie, I'm giving you this, you wouldn't have to have this memorized yet, not until we get to the thermodynamics section. 1 calorie is equal to 4.18 joules. We're using the same method to solve every single one of these problems. Since we're using the same method, what we're going to do is we're going to write our given over 120 calories over 1. Notice the units are always in the problem. We're going to put 1, we're going to use this equivalent statement, this ratio. We're going to put the 1 calorie on the bottom, so it cancels with this calorie. But if we use that part, we need to use the top part, and we're going to use this part, that's going to go on top. So your calories are going to cancel out. You enter this into your calculator. You get 502 joules. Three significant figures. Okay, let's do another one. This one's a little more complicated. We're running through a lot of problems here. This is a little more complicated, but it's not complicated if you use the same process. If the density of copper is 8.92 grams per centimeter cube, oh, look, you have a fraction right there. That's not your given. Remember, given doesn't have anything underneath. If the density of copper is 8.92 grams per centimeter cubed, how many grams, that is what you want, are in 28 centimeters cubed of copper? Okay, so a non-combo unit should be your given. In other words, a unit that is by itself. So this has got two things. It's a combo unit. That is not your given. Your given is 28 centimeters cubed. Okay, given 28 centimeters cubed. What do you want? We want grams of copper. What are our ratios? Well, let's go back on the problem. It is given in the problem. We know if you have 1 centimeter cubed of copper, it's going to weigh 8.92 grams. That's its density. If you have 8.92 grams of copper, it's going to be contained in 1 centimeter cubed. Okay, so we're going to solve this problem the same way. Write what we know over 1. We want centimeter cubed to go away. So we have a ratio right here. We're going to put this part of the ratio on the bottom, so it cancels out with this centimeter cubed. And we're going to put this on the top, so it's by itself. So you're left with grams at the top. So when you do that and you enter this into your calculator, you get 249.76. Make sure our units are correct. We're trying to find grams. Oh, look, our centimeters cubed cancel out. What's left? Grams. Oh, those units are correct. Now, we have to look at significant figures. We have 2 significant figures here. We have 3 significant figures here. Because this is multiplication, we go by the least number of significant figures. So it's 2. That 249 becomes 250 grams, the 2 significant figures. Okay, we're going to do one last one-step problem. Okay, let's say you're going to Baker, California, or Barstow, California, and you're not from the United States. It's 37 miles away, but you don't know how far that is. And you want to know how much that is in kilometers. We can solve this problem as well, right? Our given in this problem is 37 kilometers. What are we trying to find? Sorry, 37 miles. What are we trying to find is kilometers. We know a ratio that we know is that 1 mile is equal to 1609.3 meters. We know also that 1 kilometer is equal to 1,000 meters. Wait, this is going to be a 2-step problem. We're going to go through this quickly, and then tomorrow we will work on 2-step problems. Or next class period, we'll work on 2-step problems. Let's work here. Start with what's given. We are given 37 miles. We're going to put that over 1, like we've done every single time. Okay. We don't want miles. What do we want? We're trying to find kilometers. We don't want miles. We want kilometers. We don't know a relationship between miles and kilometers offhand. You can probably look one up, but right now we don't know it with the ratios I've given you. But we do know that miles is this many meters. And if we get into meters, then we can easily get into kilometers because they're within the same measuring system. So we will write down, we'll use this ratio first. We want miles to go away. So we're going to put that on the bottom. And then we have meters. Okay, so then now our miles cancel out. But we don't want meters, do we? What do we want? We want kilometers. Well, we know a relationship between meters and kilometers. We know for every 1 kilometer, you have 1,000 meters. So we're going to put this number on the bottom, the 1,000 meters, so it cancels out with this meters here. We put kilometers on the top. And look at this. Now we've got a 2-step problem. Our miles cancel out. Our meters cancel out. What unit are we left with? 59 kilometers. Our answer is 59.5 kilometers.